Hello and good day everyone. Welcome to our presentation. So I will be presenting the project overview of our smart hospitality system. The smart hospitality system is a Java-based hotel room management system developed using object-oriented programming concepts and Java Swings GUI. The purpose of this system is to help hotel staff manage room reservation efficiently. The system allows users to create bookings, process reservation, calculate payments, and store reservation data using file handling. The target users of this system are mainly hotel staff, especially receptionists and administrators who are responsible for managing guest information and reservation. In addition, housekeeping staff can also benefit from the system through better organization of room information. Overall, the system helps provide faster and more efficient hotel booking services. Next, I will explain the special features of our smart hospitality system. The first feature is the room status board, which displays the status of rooms such as available, reserved, occupied, and cleaning. The second feature is housekeeping notes, which allows hotel staff to record reminders and maintenance information. The third feature is the guest service menu. This provides additional services such as breakfast package, laundry services, and airport pickup option. Another important feature is the automatic booking ID generator. This feature automatically generates a unique booking ID for every reservation using static methods. The system also includes reservation file storage, which allows reservation data to be saved and loaded from text files. Lastly, the reservation processing system calculates reservation payments and support discount application for selected bookings. Moving on to the OOP concept, which is one of the main objectives of this project, is to demonstrate the implementation of object-oriented programming concepts. First is abstraction. We implemented abstraction using the reservation abstract class, which contains common reservation attributes and methods. Second is inheritance. The classes standard room, booking, and conference hall inherit from the reservation class. This allows them to reuse common functionality while adding their own specific features. Third is encapsulation. Important data members are declared as private or protect and accessed through getters and setters to ensure data security. Next is polymorphism. The subclasses override methods such as get confirmation details to provide different implementation according to their reservation types. We also implemented an interface called payable, which defines payment-related behavior. Additionally, we included a static nested class called client details and an inner class called reminder inside the reservation class. Finally, exception handling is implemented using the invalid reservation exception class to validate user input and handle invalid reservation data. Next is the UML diagram of our smart hospitality system. The UML diagram illustrates the overall structure and relationships between classes in the project. At the center of the design is the reservation abstract class, which acts as the parent class for standard rooms, booking, and conference hall. The payable interface is implemented by these subclasses to support payment processing functionality. The reservation class also contains a static nested class called client details and an inner class called reminder. The reservation manager class is responsible for managing reservation, including validation, searching, reporting, and reservation operation. It works together with the file handler class, which handles saving and loading reservation data from a text file. The invalid reservation exception class is used to handle validation errors and invalid reservation inputs. Overall, the UML diagram shows how object-oriented programming concepts such as abstraction, inheritance, polymorphism, interfaces, nested classes, file handling, and exception handling are integrated into the system. Finally, this table summarizes the classes used in our system and their relationship. The reservation class is an abstract class that stores common reservation details and serves as the parent class for all reservation types. Standard room, booking, and conference hall are subclasses that extend reservation and implement the payable interface. The payable interface defines payment-related behavior. The booking ID class is a final class responsible for generating unique booking IDs. And then the reservation manager class handles reservation management functions such as validation, searching, reporting, and maintaining the reservation list. The file handler class is responsible for file handling operation, including saving and loading reservation data from a text file. And then the invalid reservation exception class is used for handling invalid reservation inputs and validation errors. The mainframe class serves as the main graphical user interface of the system. Finally, client details is implemented as a static nested class, while reminder is implemented as an inner class inside the reservation class. These classes work together to form a complete smart hospitality system based on object-oriented programming principles, including abstraction, inheritance, polymorphism, interfaces, file handling, and exception handling. That concludes my part of the presentation. I will now pass the presentation to the next presenter.
So hi, my name is Nur Aisara, and I'll be presenting the file I/O section, specifically on how the system loads and saves reservation data using file handling. So this slide shows the load data feature. When the load button is clicked, the system reads from the reservation.txt file using file handler and loads all previously saved reservations back into the system. So as you can see, before loading, the reservations list is empty, and after clicking load, all the booking data appears back in the list, which proves that there is no data lost between the sessions, which can be seen on the next slide, which is the append feature. So when a new reservation is added, the system writes it to reservation.txt using append mode, and there are already 3 existing reservations in the list, and the new booking form is open to add another one. This proves that existing records are never overwritten, and each new booking are added to the end of the file.
In our reservation system, we use a custom exception called invalid reservation exception to handle invalid input data. This class extends Java's exception class and allows us to create specific error messages for reservation fields such as customer name, contact number, and check-in date. The throws clause is used in the validate reservation method to indicate that this method may generate an invalid reservation exception if any of the input data is invalid. This ensures that validation errors are passed to the calling method for handling. The throw keyword is used inside the validation method to manually trigger the exception when invalid data is detected, such as when the customer name is empty. For file handling, we use a try-catch finally structure. The try block is used to write reservation data into the file, while the catch block handles any I/O exception that may occur during the process and prevents the program from crashing. Finally, the finally block ensures that the file is always closed properly after the operation, even if an error occurs. This helps prevent resource leaks and ensures the system remains stable.
Okay, so in our system, we use several Java Swing components to build the interface. We use JList to display the list of reservation and JScroll panel to wrap it so user can scroll when the list gets along. In the new booking form, JCombo box is used to let users choose the room type. JText file is used for text inputs like guest name and check-in date, and JButton is used for the add booking and cancel actions. So for the booking details sections, use JText area to show the full reservation information of selected booking. We set it to non-editable so users can only read the details, not modify them directly. To arrange the interface properly, we use 2 layout managers. Body layout is applied to the main frame to divide the window into sections, while grid layout is used in the booking form to keep the labels in and input files neatly aligned in rows and columns. Under the File menu, we have 4 options: New clear the form, Save your work, Load a save file, and Exit close the program. This option makes it easy for users to manage their data directly from the menu bar. The View menu has one option called Generate Report. When clicked, it opens a report window that displays all reservations along with the total revenue and full booking details for each guest. The Help menu contains an About options. When selected, it shows a dialog box with the system name and version number, giving user basic information about the applications. For event handling, we use the discount button as our example. When the user clicks the button, an input dialog appears asking for a discount percentage. Once confirmed, the system calculates the discount and updates the booking details with the new discount amount. This shows how the system responds to user action in real time. We apply monospace font to the JText area in the booking details sections. Since every character in monospace takes up the same width and all the text and values stay perfectly aligned, making the booking information easier to read.
Okay, so this is our main interface for the smart hospitality system. As you can see, we have the system title and subtitle. Just below that is our toolbar with all the main action buttons: add booking, view all, save, load, remove, search, and discount. On the left side, we have the room status bar. This shows the total number of reservations and the total revenue generated. It updates automatically every time a booking is added or removed. Now let me show you how to add a booking. I will click the add booking button, which is open the new booking form. So I choose standard room and I fill in the guest name. I click add booking and the reservation get added to the list. You can see the new reservation now appears in the reservation list on the right. When I click on it, the full booking details are displayed in the booking details panel below. This uses G-text area with monospace font so everything stays nicely aligned. Now let me demonstrate event handling using the discount button. I will select a reservation from the list, then click a discount. A dialog appears asking me to enter a discount percentage. I will type 10 and I click OK, and system automatically calculates the discount amount and update the booking details with the final amount. The search buttons lets us find a reservation by booking ID or customer name. I will type a booking ID and I click OK, and the system will display the matching booking details instantly. So, how to remove a booking? To remove a booking, I select from the list and click remove. A confirmation dialog appears, and once confirmed, the reservation is deleted and the list updates automatically. Help. This has a file view and help. So help, under the help menu, the about option show a simple dialog with the system name and the version number. And next, we click save we click save to save all current reservation into a file. So the status bar at the bottom confirm it has been saved. Under the view menu, we click generate report. This open report window showing all reservation, the total number of booking and total revenue. So that covers all the main features of our smart hospitality system. The interface is built entirely using JavaScript, and all the button and menu items are handled through Action Listener and Selection Listener for event handling.